Hello, my name is Andrew Weldon, and this is a little demonstration of my code for the CA1 making a custom array class that can store multiple data types. So I'll just give you a quick run through of my H and then a quick run through of what I have in the main, and then I'll give it a run, and that will be that. Okay, so this is just my little header. It says what the class is, and also I need references and people I got to thank for this. So I'm just including an IO stream and a string for the IO stream is for the read and write, which you'll see later on, and the string is just there to take in strings because I tried it without it and it didn't work, so I had to include it. And using a namespace FTD for the fread as well. So it's a templated class using data types, so it can take in multiple types like ints, longs, floats, strings. You have multiple data types, so it's not just confined to one type. This is my constructor. It takes in p size and p row size, which is the size of the array and what to grow to in case it needs to grow. So we're just setting up pointer to the array, array, and then setting up all the variables. So m size would be equal to the p size, the parameter size. So if you set it to 10, it'll be 10 in length. Setting the number of elements to 0 because initially when you make it, it's not going to have any size, so it's going to be 0 size. And the grow size will be initialized to whatever size that you use. So we're going to construct, these are all the variables making a pointer to the variables, the int grow size, int m size, and the number of elements, and then they're constructed there. That's the destructor. If there's nothing in the array, get rid of it. Access operator, so we can put values in and out. Operator that type is a conversion operator. Returns the size, so it's not the amount of elements, it's the actual amount of size in it. This is my push function. The if statement there basically checks to see can it be added. If it can't, grow it so it can be added. So that's where grow size comes to. So it takes the size of it, takes the grow size that you take from the parameter. So if you set the p grow size to be 5, it'll add that and make it grow by 5. This if statement basically uses my binary search later on to see if the value is already there. If it's not, there's a boolean that's false. The index is set to the maximum elements, and this complexity is O to the n. And while boolean is false, you use this if statement to basically to find the correct position and then shift everything. Else if it doesn't, it adds and then it leads the loop, sets the boolean to true, and then it exits. Otherwise, it takes away, and then when it's finished, it adds to the correct amount. It adds at the end to reflect the size of the array. This is my pop function, just basically takes the maximum number of elements minus 1, and there's the pop function. So I have data type because it could be anything, pop, array, last, and then returns the pop. This is the resize function. Basically, it's nearly the exact same as when we wrote in class. It does its job so well that I didn't think there was much point changing it. I tested it a few times and it seemed to work beautifully. So you know how that works. Wrote out everything, uses a loop to go through it, copies over everything to a new array, copies everything over, and then gets rid of the old array. So this is my search. It's a binary search. I give a shout out to the website I found it on. I found it on c++.com, and I had a good look at it, and I wrote it in, and after a bit of messing with it, I finally got it working. So it has 3 values, a low, a high, and a mid, and it takes, what it basically does, it splits it up as much as it can. So it splits up the entire array, its number of elements. It keeps splitting it into halves, so it can eventually find where it is. So if it's the higher side, it'll go into this else if part and take away. eventually it will eliminate it all down to the mid. So it'll eventually find the middle point, and then it'll return that middle point based on all this. And then if it can't find it, it'll return -1. And that -1 is very important to my push function, because you don't want duplicates in it. So I have a here for push. Yeah. So search on find array, find the value. If it's -1, then you can push it in. If it's not, then it's already there, and we don't want it again. So took me a while to do that one. It took me a few minutes to get that one. The remove basically it finds out if it's in if it's either 0 position or the number of elements -1, just this line here. So it'll find out if it's in it. If it's not, then it will remove it. Then it loops through based on the specific index, and then it'll remove it, and then minus it, and then that's that removed. The clear all basically loops through every element in the array and sets it all to 0. Now I know it's not actually clearing it, but it'll set them all to a base value that, like, if it's at 0, you can kind of assume that it's been removed. Write file, gets an OF stream, called that file, called whatever the file name is. When it's open, use the loop to write whatever position I is from the array, and while it's open, it'll write everything. So if it'll write 1, then 2, then 3, then 4, because it's all sorted by the binary. And then it'll close it, return true, and boom. If not, it'll return false, saying it couldn't write. My read file, I could not get my read file working. I tried it for about 4 hours when I came home earlier on, and I can't see what's wrong with it, but I know it's not working, because it's obviously every time I run it, it won't work. But it looks to me there that, like, I can't think why it wouldn't, because it should just loop through my file, because I have a file called unordered, and I can't for the life of me see why it wouldn't work. But I'll concede that I can't get that one working. So this is my main, including the array.h, IO stream, the F stream for the read and write, Windows H for the query performance, or query time, performance counter, that's what it's called, sorry. C times time H for the clock, which counts in milliseconds, so I thought that would be very nice for performance. So all I'm doing in main is making my array, setting my clock variables, start and finish, so I know what one it is, and then my unassigned long ends for the query performance. So I'm starting the clock, starting performance count off, which count to clock cycles, and just pushing random values in that I picked. I think from 1 to 14 I have here, so I'm just pushing them all in manually, so I know if it'll sort it or not. I have here the read file. That works because I tested it without the write file, and it does work. Read file doesn't. Write file doesn't. Yeah, write file works. Read doesn't, and I don't know why read won't read it in and write it out. I haven't a clue. I couldn't get it working at all. But yeah, this just loops through the number of elements in the array, prints it out. Pretty standard. I have it here. This is my search order. So I searched for the 4th element in the array, which should be 3, because 0 and then there'd be 1, 2, and 3. So I have position 0 would be 1, 2, and 3. So it should return 3 from what I counted earlier. Yeah, I think it does, unless it changed. Testing the pop function, so I just have pop, iterate at pop. The last value I have pushed into it from all this push is, the highest value is 14, so that should be the lowest. It should be the highest, should be the last value on it, so that should be pop. The remove, removing element 4 and 5, which should be 5 and 6 in the sorted array, so that should work. This is just printing out all the elements in the array, what's there, so you'll see once I run it that 4 and 5 will then be missing from that array. This is just how long it took to take on that whole process, so it'll give you a time, see how long it took. Um, uh, Commented out because it wouldn't work, that right file stuff. This is another timeout that I start to resize it, and from 10 elements to 15. The 15 aren't used, but I just want to resize it to 15 just to show you that it works. And then it'll loop through, show you what's there, print out the size of the array, and print out the time. So, boom, we'll run it. So these are all the elements of the array. It was sorted, so just up here to show you. As you can see here, these are all indifferent, and it prints out lovely and sorted. Although I haven't a clue what this is, and I couldn't get rid of it for the life of me, I don't know what it is. There must be some kind of ghost value at the end of the array that just prints out, because 1 to 14 is the last, and that's at the end of it, so I don't know why that is there at all. Yeah, there's that one. Should be 3. It is 3. So 4, 0, 1, 2, 3. Popped. Enter it at pop 14. That's the last value. Again, I don't know what that is, John. I haven't a clue. Remove elements 4 and 4. So 4 and 4 should be 5 and 6 consecutively. There we go. These are my timers. Print out the array. Sorry. So that process took 46,797,000 clock cycles, took 24 milliseconds. The size of the array has been resized to 15, which is there on my code. Resized there 15. Elements of the array. Again, it's the same, there's nothing in the rest of them. And then from the resize and then to loop through again, it took 36 milliseconds. So that's me, and I hope this is a good enough demonstration. As I said, I couldn't get the read file working, so I apologize for that. I hope to get talking to you about it in the next class or whenever you correct this. So thanks for your time. I hope this was good enough, and we shall see you after Easter. Thank you very much.